aliens could be hiding on 4 moons of Uranus. The chance of finding life in the solar system just improved after NASA scientists discovered that 4 moons of Uranus may have oceans that could be hiding alien organisms. Experts at NASA's Jet Propulsion Laboratory, JPL, have re-examined data captured by the space agency's Voyager 2 spacecraft, which made several flybys of the planet in 1986. It suggests that Ariel, Umbriel, Titania, and Oberon could all hold vast oceans, dozens of miles deep beneath their icy crusts. Crucially, the moons appear to have enough inner heat to stop the water from freezing, giving hope that alien life could be thriving 1.7 billion miles from Earth. The oceans also appear to contain salts and ammonia, which would act as an anti-freeze, helping to keep the liquid in a watery state. The team are hopeful that the discovery will prompt a mission to Uranus to explore the water worlds, look for life, and find out how the moons generate enough heat to retain liquid water so far away from the sun. Oceans are believed to be present on moons such as Enceladus, which orbits Saturn, and Jupiter's moon Europa. But their oceans are warmed through tidal heating caused by the huge gravitational pull of the giant planets. Uranus is too small to be having such an impact on its moons, so something else must be happening, scientists believe. When it comes to small bodies, dwarf planets and moons, planetary scientists previously have found evidence of oceans in several unlikely places, said lead author Julie Castillo-Roges of JPL. So there are mechanisms at play that we don't fully understand. This paper investigates what those could be and how they are relevant to the many bodies in the solar system that could be rich in water but have limited internal heat. Scientists have long thought that Titania, the largest moon, might have retained internal heat needed to create a liquid ocean caused by radioactive decay. But the other 26 moons of Uranus had previously been considered too small to retain such heat, particularly because the tidal friction created by the gravitational pull of Uranus only has a minor warming effect. For the new study, researchers built new models incorporating Voyager and data from ground-based telescopes, coupled with findings from NASA's Galileo, Cassini, Dawn, and New Horizons missions, which discovered ocean worlds. The team used that modeling to gauge how porous the Uranian moon's surfaces are, finding that they're likely insulated enough to retain the internal heat that would be needed to host an ocean. In addition, they found what could be a potential heat source in the moon's rocky mantles, which release hot liquid and would help an ocean maintain a warm environment. Titania and Oberon had the best chance of all the moons to host life, the experts said. The oceans of the larger moons also appear to be rich in chlorides, salts, and ammonia, which would help prevent them from freezing. There is also evidence that the moons are still geologically active. Telescopes show that at least one of the moons, Ariel, has material that flowed onto its surface, perhaps from icy volcanoes, relatively recently. Planetary moons are believed to be the best chance of finding life in the solar system. The European Space Agency, ESA, recently launched its JUICE mission to survey the moons of Jupiter in the hope of picking up biosignatures like methane, which could hint that life is thriving beneath the icy surface. On Earth, extremophile life forms have been found near subterranean volcanoes and deep-sea vents, raising hopes that life could also survive in the seemingly inhospitable corners of the solar system. The new research was published in the Journal of Geophysical Research.